Good morning, Sir Benny. My name is Feng. Today I will present my Mathematics in Science project, Task 2, which is about determining the acceleration due to gravity using a simple pendulum. This experiment also compares two different graph plotting methods, which are freehand graph drawing and JSP graphical software plotter, and investigates whether different methods affect the period of oscillation. This is the aim and the theory of this experiment. The aim of this experiment was to determine the value of gravitational acceleration by using a simple pendulum, and I used plasticine as pendulum. We also want to compare freehand graph drawing with GSP and investigate whether changing the pendulum mass from 30 gram to 45 gram affects the oscillation period. According to the simple pendulum equation, the period depends on the pendulum length and gravitational acceleration. After squaring the equation, we obtain a linear relationship between t squared and length. Therefore, plotting t squared against L, length, produces a straight line and the gradient can be used to calculate G gravity. This is the experiment setup, which is two pendulum masses, 30 grams and 45 grams were used. The pendulum length was vary from 0.2 meters to 0.8 meters while maintaining a constant angle of 9 degrees. For each length, the time for 10 oscillation was measured twice, averaged and then converted into the period. After calculating t-square, graphs were plotting using both freehand drawing and also GSP. Then, the experimental results are shown in this summary table. For the freehand graph, the gradients range from 4 to 4.04, producing gravitational acceleration values between 9.77 and 9.87 meters per second squared. For GSP graph, every graph produced the same gradient of 4.03, giving a consistent value of 0.980 meters per second squared. Both methods are very close to the accepted value of 9.81 meters per second squared, showing that the experiment was successful. From the graphs, we can clearly observe a linear relationship between t-squared and the pendulum length. As the pendulum becomes longer, the oscillation period increases. This, ag- this agrees with the theoretical equation that predicts t-squared is directly proportional to the length. The straight line graph therefore confirms that the pendulum follows simple harmonic motion (SHM) under the small angle approximation. Then, the first discussion is the comparison between the freehand graph and also GSP. Although all methods produce values close to the theoretical value, the freehand graph shows slight variations. The gradients range from 4.0 to 4.04, resulting in gravitational acceleration values between 9.77 and 9.87 meters per second squared. This difference occurred because the specific line was drawn manually. Small change in the slope produced noticeable change in the calculated gravitational acceleration. In contrast, JSP used a mathematical regression line. Therefore, every graph produced the same gradient of 4.03 and a consistent gravitational acceleration of 9.80 meters per second squared. This shows the JSP provide better precision, repeatability, and objectivity. Then, the second comparison is between the 30 gram and 45 gram pendulum mass. Both masses produce almost identical oscillation periods, gradients, and gravitational acceleration values. This agrees with the theoretical equation because the mass does not appear in the pendulum formula. Therefore, changing the pendulum mass does not affect the oscillation period. This confirms one of the main characteristics of simple harmonic motion (SHM). Some experimental values were slightly higher than the accepted value of 9.81. This happened mainly because the manually drawn graph produced a smaller gradient. Since gravitational acceleration is inversely proportional to the gradient, a smaller gradient results in a larger calculated value of g. Human reaction time may also cause the measure period to become shorter, increasing the calculated gravitational acceleration. On the other hand, values lower than 9.81 occur when the graph had a larger gradient. Longer measure period caused by reaction time, air resistance, and also pivot friction increase the slope, leading to a slightly smaller value of gravitational acceleration. Fortunately, these differences were very small and are considered normal experimental errors. Several factors which affect the accuracy of the experiment. The main sources of error include human reaction time when using the stopwatch, air resistance, pivot friction, and small errors when measuring the pendulum length. Measure graph plotting also introduced subjective judgment. To improve the experiment, a photogate or motion sensor can be used instead of stopwatch. Measuring more oscillation and repeating each measurement several times would reduce random errors. Finally, using JSP instead of freehand graph drawing provides more reliable and consistent results. For the conclusion, the experiment successfully verified that the square of the oscillation period is directly proportional to the pendulum length. The result confirmed that a simple pendulum follows simple harmonic motion for small oscillation angles. The experiment also demonstrated that changing the mass from 30 grams to 45 grams does not affect the oscillation period. Although both graph plotting methods produce accurate results, JSP was more precise and consistent than freehand graph drawing. Finally, the calculated value of gravitational acceleration was approximately 9.80 to 9.81 meters per second square, which is in excellent agreement with the accepted value. Thank you.